Okay, welcome back people to the channel. Today we're going through a measurement review. Now this could be a long one, but I will put in the timings for the different parts, so perimeter, area, total surface area, volume of a trapezium, volume, etc. in the description, or you can just scroll through and you'll see the page scroll down and the transitions come in anyway for each separate section. Okay, so hopefully that helps us out. Alrighty, so first off, let's look at this one. Now, some of these because we've gone through them in a bit of detail in other videos earlier, I'm gonna go through this fairly sort of quickly, because there are some tricks that we want to be able to use. Now, you can by all means calculate each, so we're doing perimeter, so the distance needed to cover the outside of an object. We can add 4 plus 7 plus 15 plus 15, another 15 here. Okay, and then find the inside line. So we know that that's 4 and 4, and that length there is 15. Then this length here must be the difference between those. So, 4 and 7. 4 and 7 is 11. 15 take 11, so this must be 4. Okay, and we're told that this section here is 10. Okay, so you could add those 10s on as well. But the shortcut to this is, if we were to take this length here, we could extend it out to here and just say that we've got two lengths that are 15 centimeters. Okay, so if we go with that in mind, so the perimeter is equal to 15 up the top here, 15 down the bottom. So 15 plus 15, and then so we've got those two covered. Then the left and right hand side, so 15 here and same there, plus 15 plus 15. Then all I need is these two insides. Okay, and I've done, because I've already accounted for that one there down here. Let's get my highlighter on. So we've got 10 and 10, so plus 10 plus 10. So we've got 1, 2, 3, 4 15s, which are 60, plus 2 10s, which are 20, and we get 80 centimeters for the perimeter. Okay. Now we can use that same technique here, a very similar technique, as how we drag this out. So I know that on this side we've got 9 centimeters. I'm told that this is 7, so the difference between 9 and 7, that must be 2. But I also know that to get from this point here to this point here, okay, the total length of these two sides, here and here, must be the same as that. So I've just got two groups of 9. So 9 plus 9. And I can give the same method. So we know that this is 7, because those two things coincide with each other. So 7 there. And I know that the distance from here to here, the 3 plus whatever this is, must equal to 7. So I don't actually need to do a subtraction to find that, even though it's pretty straightforward. So I know that that's just two groups of 7. So 2 9s are 18, plus 2 7s are 14, and we get 32 centimeters for that perimeter. Over to our sector. So perimeter of our sector. So the perimeter of a sector is found with theta over 360 times 2 pi r. So that gives us the circumference, or the perimeter of the part of the circle. So normally this section here is just the perimeter of a circle. This section, when we put in the degrees, gives us how much we've got up there. Okay, and then we want to add the two side lengths onto that, and that's going to be plus plus 2r, because they're both the radius lengths. Okay, so we can pop that in here. So we've got 60 degrees over 360 times 2 pi, r is 6, 6 plus 2 times 6. Okay, so we can work that out again here. And we've got 60 over 360. I can simplify that to 1 over 6. 1 over 6, 2 times 12 times 12 pi plus 12. Now, I'm going to scroll down a bit, give myself some room. Now, I can make this a, so 1/6 times 12 is 2. So that would be 2 pi plus 12, and that would be our exact answer. Now, to get the approximate answer of the distance around the outside, we can go over to our calculator and punch in 2 times pi. Oh, it's not giving me anything on this calculator. What's going on there? Let's shut that down and restart it. Let's just round it to 1 decimal place. Okay, so we get 18.3. Now let's call it meters. So we've got a unit there. Always include our units. Okay, scrolling down to a slightly harder problem, or a little more complex, but the actual how to do it is not that hard. Now we've got to ask ourselves, when it's not a straight shape, so we've got to ask ourselves, what shape might this be made up of? And hopefully we can see that if we look across the top and down the sides, okay, we've got the outline of a square. And then here we've got a half circle, and here we've got half a circle. But we're going to treat that as a whole circle, 2 halves, make a whole. Okay, so once we know that, hopefully we can go, okay, the perimeter of this is going to be equal to, actually, we're not going to treat this as a square. I was thinking of it as volume for a second. We're going to treat, so we know that that length and that length are both 20, but we need to work out these lengths, which is just the circumference of a circle, because we've got half a circle and half a circle. So the perimeter here is going to be equal to 2 times 20 plus 2 pi r. Okay. Now 2 pi r, if from here to here is also 20, then half of that must be 10, which will be our radius of the circle. So 2 times 20 plus 2 times pi 10. Okay. I'm not going to go for an exact value here, I'm just going to go straight to the approximate value. So we can go over and give it, let's clear that up. And we want 2 times, 2 times 20 plus 2 plus 2 times pi, just down there. And that's all multiplied by 10 for our radius. And we get a value of 102.83, or 102.8. So 102.8, and we've got millimeters there. So that's our little run around perimeter. Okay, scrolling down to area. So the key here is to have your area equations pretty well handy. Okay, area of a triangle. Okay, so the first one, area of a triangle is equal to base times height over 2. So check out that. Now we do have to rotate this. So the height, hopefully we can see that the height is always measured from 90 degrees off one of the side lengths. So the 90 degrees off one of the side lengths is here. So that takes it up there. So that's our height. So if that's our height, our base is the 8. 8 times 5 over 2. 8 5s are 40. And divide that by 2 gives us 20 kilometres. And that's squared because it's area. Our trapezium, area of a trapezium is equal to A plus B, which is the top and bottom. So it doesn't matter which is which, we can just make that A and that B for now, times the height, and that's all divided by 2. Now these equations also come in handy when we're doing the volume of prisms as well. So let's plug that all in, and A plus B is 7 plus 10 times the height, which we're given there as 2, and that is all divided by 2. So let's have a look at that. 7 plus 10 is 17, times 2 is 34, so 34 over 2, that equals 17, and we've got units of centimetres squared. And the third one over here gives us, where are we? So here we can see we've got a, pen keeps changing to an eraser. Here we've got a rectangle. So we're going to do the area of a rectangle, which is length by width, plus the area of a sector. Okay, so the area of a sector is how many degrees the sector is made up of over 360, which is a full circle, and that's multiplied by pi r squared. All right, so first off, let's plug in our, I'm going to make this a bit bigger so it's a bit easier for us to all see it. So let's go 2 lines. So length by width, so length by width is 3 by 7 plus the degrees that the sector is made up of. Now this one we have to be careful with because we've already, the degrees here says that that is 140, but we've already accounted for our rectangle, so we don't actually need anything that falls inside there. Okay, so we need to subtract the degrees in this part of the box. Okay, now the degrees there is 90. Okay, so we're going to do 140 take 90 to find how many degrees actually make up that sector, which is the part that we're interested in, so this part here. And for that, we will get 50 degrees makes up that sector. So 50 over 360 times pi, our radius, so we can see here that that's 7. So that length here is 7, so that's our radius. And that's all squared. Okay, so we can do a little bit of working out here. We can go 21 plus, we take the 2, divide that by 10, take the 2 zeros off, that's 5 over 36 times pi 7 squared is 49. And I'm just going to stop there and put in the cas. I mean, we could go further down the line. We've done exact values earlier, so I'm not going to go every time into that. But to now, plug that into the calculator. Let's clear our screen there. And go 21 plus, get our fractions up. There's my fraction button there. Plus 5 over 36 times pi times 49. So that gives me a value of 41.507. So let's just go to one decimal place. So we get 41.507 3.5 meters squared. Okay. Alrighty, so keeping on scrolling down, we get a little bit of an extension question, and here's a good example of looking at something in terms of the two shapes that make it up. So we don't want to think about those individual sectors. So I'll scroll down a bit more here. We don't want to think about the individual sectors being really hard to find, because yeah, we might not have the skills to find these curved triangular looking pieces. We want to look at the big picture, which is made up of a triangle, and then the next bit we see, which is made up of a circle. Okay, so with that in mind, we are able to find the area of the triangle and then subtract what's missing, which is the area of a circle. Okay, so the area of this one is going to equal the area of a triangle, subtract the area of a circle. So we know that from earlier, the area of a triangle is base by height divided by 2, subtract the area of a circle, which is pi times r squared. So our base and height here, so if we look at it, we can rotate it, and our base is actually our top here. So 14, so base by our height, so you can see the height there. If we wanted to bring a 90-degree angle off, that would be the same going down there. So height is 8, divide that by 2, subtract pi times r squared, so the r is 3.2. That's squared. We can do a little bit of working out here. And 14 times 8, 8 tens are 80, 4 8s are 32, so that should be 112. 112 divided by 2 is 56. And that's subtract pi. Can't do 3.2 squared in my head, so we'll go here. Clear that off. 3.2 squared, 10.24. And let's just plug that all in now. So 56. 56 is the area of the triangle. Take away pi times 10.24. Okay, and it will do the pi times 10.24 first, because multiplication comes before subtraction in our order of operation. So your calculator will do that naturally, so we don't have to put brackets around it. Some of us might be comfortable with doing something like having brackets sit around that, but we don't actually need it. And, whoops, we go to the calculator again, rather than hitting enter on my other screen. And we've got a value of 23.83. Let's just go to one decimal place, and that is, again, millimeters squared. So that's the area of our shaded pieces there. Okay, let's cruise on down to total surface area. So total surface area, as we should remember, it is the area of each face of a three-dimensional object. Okay, we can fold these out into nets as we've seen in previous videos, and to help us get a clearer picture of it, but we're just going to dive straight into this one. So total surface area of this rectangular prism is going to be equal to, so we've got three pairs of sides. We've got a left and a right that are going to be the same, a front and a back, and then a top and bottom. Okay, so I'll label them as L, LR, FB, and TB for top and bottom. So left and right is 2 times, so that's 8 by 3, the height. You can see the height there. 2 times 8 by 3. The front and back are 7 by 3. Okay, plus 2 times 7 by 3. Plus the top and bottom. So the top and bottom is 7 by 8. 2 times 7 by 8. Start working them out. So 3 eighths are 24. 2 times that's 48. So that's the left and right side combined. 3 sevens are 21. 2 times that's 42. And then 7 eighths are 56. And 2 times that's 112. Okay, so then sum those totals. So 112 plus 48, that's going to work out nicely. So it's 160, so 202. And that's meters. Because it's an area value, it's meters squared. We need to be careful that because we're working with three-dimensional objects, but we're only doing area, so it's squared. Okay, over to our square-based pyramid, and the TSA there is going to be equal to, we can see we've got 4 equal-sized triangles that make up the top, and they are, we know that triangles are base by height divided by 2, so base is 8, height is 10, and that's all divided by 2. And then we're going to add the square base to it, so that's 8 squared, or 8 times 8. So the triangle, let's have a sip of water. So the triangle is 8 by 10 divided by 2, so 8 tens are 80, divide that by 2 is 40, and then 4 times 40 is 160. 8 eighths are 64. So summed, they are 224. And let's make sure we always put our units in. Next one, total surface area of a cylinder. So this is got a bit to it. Total surface area of a cylinder is the 2 circular ends, so 2 times pi r squared, plus the cylindrical body, which is the length by width, because when we roll it out, we'll remember it becomes a rectangle. So one of the lengths will be 11, but the other length is the same length as the circumference. Okay, so it's 2 pi r, sorry for the stutter, 2 pi r times the height, or 2 pi r h. Okay, so now we've got that in there. Go 2 times pi times the radius squared, which is 3 squared, plus 2 pi times 3 times 11. Okay. Now, sometimes we get a pretty neat exact value here, so I'm going to keep going through this. So 3 3s are 9, 2 9s are 18, so that's 18 pi, plus 3 times 11 is 33, 2 33s are 66, so that's 66 pi. And then we've got like terms here in 18 pi and 66 pi, so that'll be 84 pi. Hoping my mental maths is okay. Okay, so that's the exact value, which is nice and neat. Now for the approximate value, we will go across our calculator and go 84 and give me pi. Just about need a shortcut for that. 84 pi is equal to 263.89. So let's go to 2 decimal places. Ooh, where is my pen gone? 263 one decimal place. 263.9, and that is millimeters squared. Okay, going down to a slightly harder one. So this one, total surface area of a cylindrical sector, we can actually express as a fairly long equation, but once we've got it as that equation, it's easy just to plug in a few numbers. So total surface area of a sector So TSA with the sector is equal to, got on my notes down here because I didn't want to get it wrong, 2 times theta, the angle over 360, times pi r squared. So that gives us the two partial ends. So we've got 2 here, it's going to be a quarter of a circle, or 90 degrees over 360, which is going to give us 90 degrees over 360, which is the same as a quarter. So that's the two ends, plus, where is it on my notes? Sorry, I keep looking down, I can't see it. Plus the cylindrical body, so that's theta over 360 times 2 pi r h. So that bit there, this bit here, the cylindrical body, is the same as our body up here, but we've added the degrees over 360 to tell us how much of that we have, so it's only a fraction of a circle. And then the last bit is 2hr plus 2 times the height, 2 times the height times r. And that gives us these flat rectangular pieces at the back and on the bottom. Because 2 times, so we've got 2 of them, h times r is that length, the height of the, if we stood it up, the height, so 10, by the radius, which is 6, and we've got 2 of them, so that would give us both of those. Okay, so now what we need to do is plug in our values. Okay, so we can go equals 2 times theta, so that's 90 over 360, times pi 6 squared, plus theta is the same value again, times 2 pi r times h, which is 10, plus 2hr, so 2 times 10 times 6. Now, I can put that straight into the calculator using my fraction button, etc., putting all the squares in the right place. But because that's quite long, I'm going to clean it up a little bit. So I'm going to look at cleaning up each term individually. So remembering that each term is separated by a plus or a minus. So we've got one term here, one term here, and one term here. Okay, so I'm going to clean them up separately, see how far I can get. So 6 6 is 36. 2 times 36 is, actually I'm going to go a quarter of 36 because I know that this is a quarter. A quarter of 36 is 9. Okay, so 9 times 2 is 18, so that gives me 18 pi, plus, I'll make sure it lines up nicely. This one is 6 times 10 is 60. 2 times 60 is 112. A quarter of 60 is, sorry, 2 times 60 is 120. A quarter of 120 is 30. So that'll be 30 pi, plus 2 times 10 times 6. So 6 tens are 60. 2 times that is 120. Okay, so that's looking much easier now. I can even clean that up further because I've got 2 like terms here. So like terms there and there. I can continue with that. So that's 48 pi plus 120. And that would be as good as we can get for an exact answer. I can now also put that into the calculator really easily. Like I said, if you're okay with it, start here, especially if you're not confident with doing the multiplication of each term, you can start here and just be careful putting it into your calculator, okay? And, sorry, my wife is just texting me, it's going off like nuts. But now I find that really easy to put in my calculator and just go 48 times pi got a pi button, try to always use it instead of an approximation. Plus 120, and we get beautiful 270.796. Let's go to one decimal place again. So 270.8. Point 8 and total surface area, so it's meters squared again, and that is the surface area of a sector. Now that one's sort of long, but like I said, if you can just write down that equation, okay, and then just plug in r and h and theta if it comes up, you're perfect. You can use that equation for a whole circle. And the thing there is that theta becomes 360, which is 360 divided by 360 is 1, so it doesn't actually count. That's why we just remove it for a whole circle. Alrighty, scrolling on down to volume and our last little bit of this video. So, volume, easiest way to think about it is we find the area of the face or area of the cross section. Cross section is a shape that continues all the way through the prism unhindered. Or if we cut, so that triangle there, if we cut this in half down there, we would get that same triangle coming up. Okay. Same here, the trapezium here, if we cut this shape in the middle here, we'd get that trapezium shape again. If, however, we look at this rectangle, and we followed that all the way through, if we cut our shape here, that rectangle would be a smaller version, so it's not the same shape. Okay, so let's get cracking into it. So we want to do volume is going to be equal to the area of the face, times the depth. Okay, area of the face here is a triangle, so we've got base by height divided by 2, and the depth is 10. So let's plug those in. So it's 3 times 5 over 2 times 10. 3 5s are 15, divided by 2 is 7.5, times 10 is 75. Again, you can put that all into the calculator and it will spit it all out nicely. Now that's in meters. It's volume, so it's always raised to the power of 3, volume cubed. Here our trapezium is, so the volume is the area of the face, which is A plus B times H, all divided by 2, multiplied by the depth. So let's plug that in, A and B, so the top and bottom, doesn't matter which is which, so we've got 10 plus 6, 10 plus, it's going to look like a multiplication if I do that, mess that up. Okay, so 10 plus 6 times the height, which is 5, all divided by 2, multiply that by the depth, which is 12. So you can see that going back. There is 12. Alrighty, let's smash out some of this. 10 plus 6 is 16. 5 16s are 80. So yeah, 5 16s are 80 because 5 10s are 50. 5 6s are 30, so that's 80. Divided by 2 is 40. And that's all multiplied by 12. Now your 40 times tables may not be fantastic, but if we think about this as, let's do it in a different colour, as 4 times 12, hopefully we know that that's 48. But I need to add a 0 in the end because I took one off, which means we'll get an answer of 480. 480 centimetres cubed. Volume of a cylinder. Okay, the face is a circle, so we want pi r squared. And we times that by the height, which is 2. Okay, let's make sure that we get r correct. Now we're given the diameter there, so we want to half that. Half of 8 is 4 by 2. So 4 fours are 16. So 16 pi times 2. And 2 16s are 32, so 32 pi. So that's our exact value for, well, we'd have to have centimetres cubed there. And then to get the approximate value, you can put it into the calculator. Swipe over here. Get rid of my... Where am I? 32 pi. Need to get rid of that. Second pi. 32 pi is 100.5 if we round it. Centimeters cubed. And you can see that if you think about pi is approximately 3.14. So if we go, what, 32 times 3.14, you know that we're getting close to 100. Okay, so you know that that's right. Okay, last one is down, a little bit of an extension question. And we want to take a look at this. Now this does look a little bit intimidating at first. But if we want to think about it, we go ask ourselves, right, how do we find the area of that face? Because once we've found that, all we have to do is multiply it by 6 to get the volume. Okay, and I say to myself, well, that area, it looks like what I've got here is, if I can get maybe a thicker text will help. What I've got here is basically a square that's had a chunk which is the shape of a quarter circle taken out of it. So if I find the area of a square and subtract that quarter circle out of it, then I'm going to get effectively that area there. Okay. There are other ways you can do it, but I think this is the quickest one and the simplest one. So let's focus on finding the area of that face first. So the area of the face is going to be equal to a square take a quarter of a circle. Okay, so that's equal to 4 squared, so 4 times 4, subtract a quarter of the area of a circle, which is pi times r squared. R is actually 4 here, okay? So we've got to imagine this circle as continuing around. It's going to be quite a poor circle, I think. Okay, continuing around, so from here out is the radius, so that's 4. See if I can get rid of that. Clean that up. So R is, what did I say? 4. 4 squared. Okay, so now I've got 4 fours are 16, minus a quarter of a circle, 1/4 of pi times 16, which is 16 take 4 pi, because a quarter of 16 is 4, so that's where I got 4 pi from. Now, let's pop that into the calculator. Clear that up. I've got 16 take, oops. 16 take 4 times pi. Now we know that this is going to be pretty, I guess, relatively small, because 4 pi is approximately 12. So we should get something just under 4. And there we have it. Okay, so that answer, we have to remember, is not the complete answer. That's 3.4. I'll round it to that now. But the volume, because that's 3.4 centimeters squared, that's the face, which is here. The volume, however, is 3.4 3.4 times 6, because that's our depth. Okay, so let's go over to our calculator again and multiply our answer by 6. That equals, actually I'm going to change that because I rounded it earlier and I used an unrounded answer. So let's go back here and just put in 3.4 times 6. Okay. So I just wanted to be accurate to the use of that rounding earlier. Sometimes we may want to keep the unrounded answer. So 20.4 centimeters cubed. So hopefully that helps you with your measurement revision and a bit of a recap. If you've got any comments, leave them below. That's been a bit of a long one for me, considering most of the video is about 10 minutes. I reckon that feels like 20. But hopefully it's useful. Hopefully, if you've got questions, leave them below. If you like it, give it a thumbs up, subscribe, share it with people if they don't know it's around. And other than that, have a fantastic day. See you again.